statements and logical connectives. In this lesson, and in the lessons to come, we will start studying logic and how it can be used to analyze and understand statements. The statements that we encounter in our everyday lives. There's statements that appear in advertisers' claims and political statements. There are statements that appear in legal documents, credit card statements, car loans, home rental agreements, and so many more. So I think you're going to enjoy studying logic. To get us started, let's talk a little bit about the history of logic, just real briefly. So the ancient Greeks were the first people to systematically analyze the way humans think and arrive at conclusions. Aristotle organized a study of logic for the first time. As a result of his work, Aristotle is called the father of logic. The logic from this period, called Aristotelian logic, has been taught and studied for more than 2,000 years. Gottfried Leibniz had a deep conviction that all mathematical and scientific concepts could be derived from logic. He became the first serious student of symbolic logic and is also one of our prominent mathematicians. English mathematician George Boole is considered to be the founder of symbolic logic because of his impressive work in this area. Mathematician Charles Dodson, actually I think I've written the name wrong. Let me correct his last name. There we go. I think I was missing a G. But anyway, mathematician Charles Dodgson, better known as Lewis Carroll, incorporated many interesting ideas from logic into his books, Alice's Adventures in Wonderland and Through the Looking Glass. So that's really fascinating. And many other stories that he wrote for children. The study of logic is also a good preparation for other areas of mathematics like probability. And so this is a great segue into where we'll be heading in our studies. Now, we use many connectives, is what they're called, many words or phrases to connect ideas or thoughts, such as the word and, or, and if then, right, to connect thoughts. And these are called connectives. For example, in this statement, a judge announces to a convicted offender, I hereby sentence you to 5 months of community service and a fine of $100. In this case, this word and indicates that both events will take place. So this person has to perform community service and also pay a fine. So this word and here is the connective, meaning both of these events or both of these situations must take place. As opposed to, I sentence you to 6 months in prison or 10 months of community service. The connective here is the word or. Now, this or here is an exclusive or. When we use an exclusive or, it means one or the other of the events can take place, but not both. Now, let me give us an example of an inclusive or. In a restaurant, a waiter asks, may I interest you in a cup of soup or a sandwich? This here is an example of the inclusive or. Now, we call it such because one or the other or both events can take place. In other words, you can say, I'd like to order soup only, or I'd like to order a sandwich only, or you may say, yes, I'll take a cup of soup and a sandwich, right? So this is an inclusive or. So when we're studying, when we use the word or in a logic statement, it will mean the inclusive or, unless stated otherwise. So whenever we see the word or, we are assuming that it is the inclusive or, unless it is stated otherwise. All right? All right, so we're going to be looking at statements. A statement is a sentence that is either true or false, and you and I are going to have to determine whether the statement we're considering is either true or false. Okay, like for example, if we say, The Empire State Building is in the state of New York. Like, you would have to determine, is that statement true or false? Or the NBA team from Portland, Oregon is the Lakers, right? That's a statement. It's a sentence, but that statement is false. Whereas the previous statement that I mentioned about the Empire State Building, that's a true statement. So you and I are going to be looking at statements, and there's different kinds of statements. And you and I are going to have to determine, is this statement true or is it false? That's called assigning a truth value. Assigning a truth value to the statement. We're going to start by looking at simple statements. Simple statements convey one idea, while a compound statements those are sentences combining two or more ideas. Now, when we change a statement to its opposite meaning, we are now considering the negation of a statement. The negation of a true statement is always a false statement, and the negation of a false statement is always a true statement. Now, we're going to have to be very careful when we're negating statements that contain these words, all or none or some. These words are called quantifiers, and we're going to have to be very careful when we are considering the negation of a statement that has quantifiers. All right, we're going to have to be careful. For example, look at this statement. All lakes contain fresh water. Okay, first of all, we know the statement is false, right? For example, there are some lakes that contain salt water, like the Great Salt Lake in Utah, right? The Great Salt Lake in Utah contains salt water, obviously. So this is a false statement. So when we consider the negation of this statement, the negation of this false statement has to be true. But what would the negation of this statement be? What if I said, okay, the negation of this statement, meaning the opposite, the negation of this statement is no lakes contain fresh water, right? So instead of all lakes contain fresh water, what if I said the negation is no lakes contain fresh water? Well, this can't be the negation, because this is also a false statement, because there are some lakes that contain fresh water, right? And so this can't be true. So this can't be the negation. So what is the negation of all lakes contain fresh water? Now remember, whatever we propose must be a true statement. So the negation can be written this way: not all lakes contain fresh water. This is not the only way to express the negation. You could also say at least one lake does not contain fresh water, or some lakes do not contain fresh water, right? But this is a true statement. Let's look at another statement just to really make sure that we're honing in on this idea of negating a statement, all right? All right, check this out. No birds can swim. Okay, now, I hope we all agree this is a false statement. There are plenty of birds that can swim, like the penguin, for example, right? Is just one example of a bird that can swim. So this statement is false. So therefore, when we consider its negation must be a true statement. Now, what if I said, okay, the negation is all birds can swim? This cannot be the negation, because this is also a false statement. Not all birds can swim. And so this can't be the negation. So then what is the negation? Well, let me get this one off the board here, because this is not right. Some birds can swim would be the correct negation. Or you can say it differently too. You can say something like, at least one bird can swim. Now this is a true statement and is the negation of no birds can swim. All right, let's look at some statements that involve the quantifier some. All right, so remember, this is called a quantifier, some. All right, so some students have a driver's license. Okay, this statement is true. So therefore, its negation must be a false statement, right? So what would be the negation of this statement? Now, first of all, some students have a driver's license implies that at least one student has a driver's license, right? So therefore, the negation of this statement, which must be a false statement, is no student has a driver's license. That would be a false statement. All right, which is a false statement, which we needed to construct. All right, very good. Here's a little summary of what we've mentioned. So this is the type of statement that we're considering, and then its negation. Okay, so if you say, or if a statement says all are, the negation would be some are not. Okay, if the statement is none are, then the negation would be some are. If the statement is some are, the negation would be none are. And finally, if the statement says some are not, the negation would be all are. Now, this little diagram may be helpful for us to help remember statements and their negation. So if the statement is all are, then its negation is some are not. If the statement is some are, the negation is none are. So the quantifiers diagonally opposite each other, are the negations of each other. Okay, so maybe this might be helpful. All right, we've come to our very first official example. Write the negation of each statement below. All Cocker Spaniels are dogs. Some insects are mammals. Some days are not Mondays. No coins have the image of Abraham Lincoln. I would actually encourage you to pause this lesson right here and try to construct the negation of each statement. Go ahead and do that now. All right, let's tackle the first one. All Cocker Spaniels are dogs. First of all, this is a true statement. That's important that we assign a truth value to this statement, because now we understand that its negation must be false. So remember what we mentioned earlier when they use the quantifier all are, all, I'm going to underline that. We mentioned earlier this quantifier all are. That means the negation is some are not. Therefore, the negation must be some Cocker Spaniels are not dogs. All right, and which is a false statement, right? Some are not. That's the quantifier. And of course, this statement is a false statement. Let's go to the next one. Some insects are mammals. Again, the quantifiers here are some are. Some insects are mammals. Okay, this is a false statement, which means that its negation must be true. The negation of some are would be none are. Some are is the negation would be none are. Therefore, the negation has to be none of the insects are mammals. Another way to say that, of course, is no insects are mammals. You can say it that way as well. And this is a true statement. All right. Some days are not Mondays. This is a true statement, right? Sunday is a day and it's not Monday, right? Tuesday is a day and it's not Monday. So some days are not Mondays. That's a true statement. Therefore, its negation must be false. The negation of some are, let me write that in red here so it can pop a little bit. Some are. The negation, therefore, is going to be all are. All days are Mondays. And of course, that's a false statement. It needs to be false. All right, very good. Last one. No coins have the image of Abraham Lincoln. Now that's a false statement, right? Because pennies, right? Pennies have Abraham Lincoln on them. So this is a false statement. Okay. The quantifier here is the word no. It's kind of similar to none, right? None or no, right? So and this is a false statement. Now that's important because now we understand that its negation must be true. So when we say no coins, that's equivalent to saying none, right? So therefore the negation is some coins have the image of Abraham Lincoln, which of course is true. All right, so I hope this example really drives home the point of how we need to be careful when we're considering the negation of a statement. Now, we mentioned earlier that compound statements are statements that consist of two or more statements, and the connectives that we use to join two statements are connectives like the word and or if then or if and only if. All right, and so also the word not is generally used to negate a statement. All right, so when we look at all of these words up here, these are used to join two or more simple statements. So these are using compound statements. Actually, this I misspelled something here. This should be the word statement or statements, right? Okay, good. We consider a simple statement that has been negated to be a compound statement, and the way that's going to appear many times is with this word not. All right. Now, as far as symbols are concerned, if P represents a simple statement, then not P would be written like this, with this symbol right in front of it. Okay, so this symbol here is used to negate a statement. It is interpreted as the negation of P or not P. Okay, now generally speaking, we use the letters P, Q, and R to represent statements. Okay, that's convention. The convention of letting letters P, Q, and R represent statements. And when we want to negate a statement like P, Q, or R, we use this symbol here to negate that statement. Okay, now the conjunction is symbolized by this symbol here, and this is read as and. What I want you to think about is this symbol here kind of looks like an A without the bar across, and so this here means and. Okay, so it's a conjunction. All right, here we go. Example number 2. The following statement involves John Batista, I think that's how you pronounce his name, an American jazz musician, band leader, and TV personality. Well, what we want to do is write the following conjunction in symbolic form. John, I think misspelled his name here. John, okay, is the leader of the band Stay Human, but John is not playing the Chicago Festival. All right, now listen. We're going to choose letters to represent simple statements, okay? Letters like P, Q, and R, all right? But remember that when we choose a letter to represent a simple statement, we choose letters like P, Q, and R to represent statements that are not negated. So for example, I'm going to let P represent the statement that John is the leader of the band Stay Human. And then the next statement, maybe I'll choose a letter Q. I'm going to let Q represent the statement that John is playing the Chicago Jazz Festival. Remember, we choose letters like P, Q, and R to represent statements that are not negated, all right? All right, so we have P and Q, and they each represent these two simple statements. Therefore, in this statement in symbolic form would be P and not Q. I use lowercase letters here, and then I'm using capital letters here. Maybe I should rethink that because I don't want to confuse anybody. So let me P and not Q. That would be this statement in symbolic form. Now here, I want to mention that the conjunction used here is the word but. All right, that's the conjunction that is used here. So the conjunction is not always the word and. The conjunction could be and, it could be the word but, like in this case, or the word however, or the word nevertheless, right? So the conjunctions appear in different ways. Now we move to the disjunction. The disjunction is symbolized by this symbol here and read or. So this symbol means or. Now remember that the word or that we use in our studies is the inclusive or, not the exclusive or, the inclusive or. All right, here we go. Example 3. Let P represent this statement. It's a simple statement. Camila will take chemistry. And let Q represent the simple statement. Camila will take French. So what we want to do is write the following statements in symbolic form. Camila will take chemistry, or Camila will take French. Let me put some spacing here so that we can show what these are in symbolic form. All right, so for the first one, Camila will take chemistry, that's P, or that's this disjunction symbol. Camila will take French, so it's P or Q. So that's the answer. That's the first statement in symbolic form. Next, Camila will not take chemistry. That means not P. Or Camila will not take French, not Q. So not P or not Q. Finally, Camila will take French. That's Q. Or Camila will not take chemistry. So that's Q or not P. All right, check this one out. Let P represent the simple statement that dinner includes soup. Let Q represent the statement that dinner includes salad. And let R represent the simple statement dinner includes the vegetable of the day. It's bothering me that dinner is not capitalized, so let me fix that for us. All right, write the following statements in symbolic form and then indicate whether the statement is a negation, a conjunction, or a disjunction. All right, the first one, dinner includes soup, comma. Now, it's going to be very important that we pay attention to the commas because the comma will group certain statements together. And whatever statements are together, grouped together, we want to use parentheses. So dinner includes soup. That is P, statement P. And salad or the vegetable of the day. All right, so the and, first of all, is this symbol. All right, now right here, salad or the vegetable of the day, this is on the right side of you, if you will, of the comma. So that means salad or the vegetable of the day needs to be grouped together. Okay, so I'm going to use parentheses. Dinner includes salad is Q, or the vegetable of the day, that's R. So this is the statement, dinner includes soup and salad or the vegetable of the day. Now, is this a negation, conjunction, or disjunction? Now, there's no negations at all here, so it's not a negation. So it's basically, is it a conjunction or a disjunction? All right, so we always evaluate this information within the parentheses first. So since the conjunction here is outside the parentheses and it's evaluated last, this statement is considered a conjunction, okay? I'll say that again. Because this symbol here is outside of the parentheses, that means we will consider that operation or that conjunction last. Therefore, this entire statement is a conjunction. I'm going to go ahead and document that for us. So this statement here is a conjunction. All right. I always tend to think of it as, what symbol do you see outermost? Outermost, right? And that'll give it away of what kind of statement you're looking at. All right, let's go for the next one. Dinner includes soup and salad. Okay, soup is P, salad is Q. It says P and Q. But notice that there's now a comma. So that comma is grouping P and Q together. Okay, so this is soup and salad. And then after the comma, it says or the vegetable of the day, which is or are. Okay, now this symbol is a conjunction. It's inside the parentheses. What is outside the parentheses is considered what is happening last or outermost, and you have a disjunction here. So therefore, this entire statement, the entire statement, is a disjunction. All right, now it's going to be turned around on us, whereas the symbolic form is given, we have to give the statement in words. All right, so let P represent the statement. It's a simple statement. The house is for sale. Q represent the statement. Again, the simple statement. We can afford to buy the house. All right, so this is the first statement that they want us to write in words. P and not Q. P means the house is for sale, and that's this conjunction. Not Q means we cannot afford to buy the house. I hope that one's clear. Let's go to the next one. Not P means the negation of this statement that the house is for sale, or not Q means the negation of this second statement. So therefore, this statement is the house is not for sale, or we cannot afford to buy the house. Finally, it's the negation of this statement. So P and Q would be, let me read this first, okay, because there's parentheses, so read this first. And then the outermost is the negation. So this entire statement here is a negation, because the negation symbol is used outermost, okay, or last. So read this first, P and Q. That means the house is for sale and we can afford to buy the house. But it's the negation of that statement, the negation of this statement. So it can be read in the following way. It is false that the house is for sale and we can afford to buy the house. Now, one thing we want to keep in mind is that the word but may also be used in a conjunction. So, for example, you know this answer here, the house is for sale and we cannot afford to buy the house. You could also say the house is for sale, but we cannot afford to buy the house. So this word and could be replaced with but. So this entire statement here, the first one here, this is a conjunction. I want to just kind of label that here, a conjunction. That's what kind of statement this is. This here is a disjunction. I want to label this. This is a disjunction. Okay. Again, the outermost symbol is the disjunction. You know, you could, if you wanted to, you could put parentheses on the second symbolic form as not P or not Q. In other words, I'm just trying to emphasize that the outermost symbol here is the disjunction, is the or. Here, this is a negation, all right, or a nor statement, okay? This is the outermost symbol here. All right, very good. Okay, now let's talk about if-then statements. So these are conditional statements. So the conditional is symbolized by this symbol here, kind of like an arrow going to the right. And the way we read this is if-then. If-then. So the statement, for example, this statement here would be read as if P, then Q. if P, then Q. Now, for the if-then statements, these conditional statements, you have two parts, okay? You have the first part that precedes the arrow. This is the antecedent. And the part that follows the arrow is the consequent. So this is the antecedent, P is the antecedent, and Q is the consequent. All right? Now, sometimes in a conditional statement, the then part of the if then statement is not explicitly stated. For example, if you get an A, I will buy you a car. Kind of a good deal, isn't it? Anyway, the if statement is right here, the antecedent. This would be your P, right? If you get an A, then I will buy you a car. The then is not written, it's not explicitly given, but it's implied. So if you get an A, I will buy you a car means if you get an A, then I will buy you a car. Sometimes the then is written here on the consequent, other times it's not. Okay, example 6. Let P represent the simple statement, the shoes were purchased at the thrift store. Let Q represent the simple statement, the outfit was expensive. All right, we want to write the following statements symbolically. All right, first, if the shoes were purchased at the thrift store, comma, then, so this is an if-then statement. This is a conditional statement. Then the outfit was not expensive. All right, let's go for it. So if the shoes were purchased at the thrift store, that's P, right? Then that means we have to have this arrow, right? If this is true, the shoes were purchased at the thrift store, then the outfit was not expensive. That means not Q, because Q represents the outfit was expensive. Cool. Next, if the outfit was expensive, that means Q, then the shoes were not purchased at the thrift store. That means then not P. So Q, then not P. All right, very good. It is false that. All right, that's a negation, everybody. It is false that. I think we need to open up a set of parentheses because they're about to tell us what we want to negate. It is false that. If the shoes were not purchased at the thrift store, that means not P, then the outfit was not expensive. So that means not Q. Close the parentheses there. So the negation of if not P, then not Q. All right, cool. Let's try another. All right, example 7. These are fun, right? Let P represent Jorge is enrolled in calculus. Q, Jorge's major is criminal justice. R, Jorge's major is engineering. Write the following symbolic statements in words and indicate whether the statement is a negation, conjunction, disjunction, or conditional. Remember, for that last part, we need to look at the outermost symbol, or the symbol that is read last or considered last. All right. This says, if Q, then not P, or R. All right. If Q, that means if Jorge's major is criminal justice, then Jorge is not enrolled in calculus, or Jorge's major is engineering. But you see the use of the parentheses here. So when we write this out in words, we want to make sure we separate all of this part with a comma, right? Separating all of that from this last part. So it should be written like this. All right, so here it is written. If Jorge's major is criminal justice, then Jorge is not enrolled in calculus, comma, right? That's the denoting the parentheses. Jorge's major is engineering. Now, this statement, if I read the symbolic form, the outermost symbol is here, and it is a disjunction. I'm going to label this a disjunction. Remember, look at the outermost symbol, all right? Disjunction. All right, next. If Q, then not P or R. All right. If Q means if Jorge's major is criminal justice, then Jorge is not enrolled in calculus or Jorge's major is engineering. Again, when we begin to write this statement, we want to precede it with a comma because this is grouped together. Let's try this. All right, I think we have it. If Jorge's major is criminal justice, comma, then Jorge is not enrolled in calculus or Jorge's major is engineering. All right, because this symbol is outside of the parentheses, this entire statement is considered a conditional statement. So I'm going to write conditional. All right, very, very, very good. Okay, last one, folks, the biconditional. The biconditional is symbolized by that same arrow that we use for a conditional, but it's going in both directions. And this is read if and only if. Sometimes we abbreviate if and only if by spelling out if but with two F's. If you see IFF, that means if and only if. All right, here's our example that illustrates the biconditional statement. All right, and it's our last example. All right, example 8. Let P represent the simple statement Alex plays goalie on the lacrosse team. Let Q represent the simple statement the Huskies win the Champions Cup. All right, write the following symbolic statements in words. Now this says P, if and only if, Q. Alex plays goalie on the lacrosse team if and only if the Huskies win the Champions Cup. All right, and we can write that in words. Alex plays goalie on the lacrosse team if and only if the Huskies win the Champions Cup. All right. We'll talk about this more later, but what this really means, the if and only if, it means Alex plays goalie on the lacrosse team if the Huskies win the Champions Cup, and if the Huskies win the Champions Cup, then Alex plays goalie on the lacrosse team. In other words, that conditional statement goes both ways. That's why you see an arrow going in both directions. I'll say that one more time. Actually, I think I'm gonna write it for us. So this really spells out that if and only if meaning, right? Alex plays goalie on the lacrosse team if the Huskies win the Champions Cup, and the other direction. If the Huskies win the Champions Cup, then Alex plays goalie on the lacrosse team. That's what is meant by if and only if. Now, this statement here in yellow, the if and only if statement, kind of summarizes all of this in a neat, concise way. So that's why we prefer to write it this way. All right, let's go for the next one. We have Q, if and only if, not P. So the Huskies win the Champions Cup if and only if Alex does not play goalie on the lacrosse team. Very good. And then, last but not least, it is false that Alex plays goalie on the lacrosse team if and only if the Huskies do not win the Champions Cup. All right. Super cool.